Hello, this is Alexis, a student passionate about space. Today, I will present to you the project I worked on during my internship at Luos. I'm a student at Estaca, a French engineering school specializing in space engineering. This year, I'm invested in one of my school's association, ISO, which stands for Estaca Space Odyssey, and permits me to realize and launch space-related projects. I am particularly working on my association's most ambitious project, named ESL-1, which has for objective to beat the actual European altitude record for an amateur space rocket, which is an altitude of 32 kilometers at the moment. Realizing more ambitious projects adds up new issues, which implies a change in the technological choices, including the electronic system. This is where Luos comes into play. Indeed, when I first heard about Luos, I immediately saw that this technology was adapted to the new association's issues, and this is what I am going to present in this video. First of all, what are the objectives of the electronic system in a space rocket project? Objectives differ from one project to another, but there are two main objectives common to all projects: the retrieving/storage of data and the release of one or several parachutes. I decided to focus on the release of parachutes for my proof of concept. Therefore, the system I designed allows to deploy two parachutes, the first one at 32 km altitude and the second one at 1 km altitude. To do so, I use a barometer and two solenoids. As you can see in this illustration, the principle is to calculate the altitude from the pressure retrieved by the barometer, detect both release timings, and finally activate the solenoids at each timing. Let's see the first part of my system. As developed by Luos and its microservices philosophy, I divided my system into three services. The first is for my barometer, the second for the app barometer, and the other for my solenoids. The barometer service includes an SPI driver used for the communication board components, the pressure retrieving, which uses the SPI driver to read the barometer's pressure, and a Luos communication part, which permits exchange with the other system's services. The app barometer service permits calculating the altitude thanks to the pressure retrieved by the barometer service. This service detects 32 km altitude and sends this information to the solenoid thanks to the Luos communication part. Finally, the solenoid service permits the activation or deactivation of the solenoid when the Luos communication part receives the order. This first system allows us to verify that we can determine an altitude with the barometer and then activate a solenoid when a certain value is reached. As a reminder, the solenoid will release the parachutes. Okay, now for the second part of my system, the only difference with the previous one is that our solenoid service is now on an Arduino MKR0. Why this modification? Our electronic system will include a telemetry part that I have been working on, which is already finished. This project uses a specific unchangeable board that cannot support the whole system because of the number of components used. Therefore, a second board is needed. This modification only took me a few minutes because Luos allows you to move services easily in your system. I just copied and pasted the service from one board to another and changed some of the functions that were specific to the Nucleo F072RB board. This property is one of the main advantages that made me choose Luos. The ability to easily change the location of your component from a hardware and software perspective is very important. As our project lasts during 5 years and is made by different students, some of the choices might change during the development. Moreover, the services can also be transmitted from one project to another, meaning that we won't need to develop the services used in our rockets again, which permits us to gain a lot of development time. Let's discover my third system. The difference here is that I added a second solenoid. This modification was very easy to do, as I only needed to copy-paste the solenoid service and change some definitions, such as the pins connected to the solenoid. This property given by Luos also is very important for my project. Indeed, if one of our components fails and makes the whole system non-functional, we will be highly exposed to rocket crash, meaning that we will lose years of work because of one failure. We can't take this kind of risk. Therefore, we add redundancy to our system, which means that we don't use one, but multiple components of the same type. If one or two fails us, the system remains functional. Therefore, being able to multiply the number of components easily is very interesting. To summarize, Luos allows us to quickly move a component in our system, reuse part of the code in the next project, and easily add redundancy. The last Luos tool I used is Pyluos. This tool permits visualizing and controlling the system from a computer using a Python script. This tool is very useful for my project because it allows a simulation of the pressure decreasing during the flight. Therefore, we can see how our system will respond to this evolution to verify if the parachutes will be ejected at the right timings during the flight. This kind of simulation will be hard to reproduce in reality because the pressure goes down to 850 pascals at 32 km altitude. Testing a system with Pyluos permits to save money and time. The first thing I execute in my script is visualizing the system. We can see the services and the nodes of our system. Then, I create some pressure values corresponding to a possible evolution of this parameter during the flight. You can see this evolution on the graph right here. The next step takes more time as I send all the pressure values to my app parameter service, retrieving the corresponding altitude. Thanks to the light on this relay, you will see when the solenoids are activated. We will imagine that there are solenoids linked to these relays that will get activated at the same time. During this process, I also ask for the state of the solenoid, which I save to see if it's activated at the right time. You noticed that there is a third board in this system. This board is a Nucleo L073RZ and includes the services gate and pipe, which permits to use Pyluos. Now that this step is done, we can visualize the altitude returned by the app parameter service. Let's continue with another graph. I made a figure that allows the visualization of the pressure in green, the altitude in blue, and the solenoid's activations in red. We can see that the solenoids are activated at the right timings, which I also verify here. So, the first solenoid gets activated at 32 km, and the second at 1 km as expected. This system is functional. Cool! It's always better with parachutes, unless you don't like your neighbors, of course. Through this video, I made a quick presentation of the project I worked on during my internship, and I will keep working on it in my association as we still have a lot of choices and developments to make, such as the final objectives of the system and what components will be implemented in the final system. Feel free to ask your questions on the Luos Discord in the channel Projects. I will be happy to talk more about it with you. If you are interested in this project, you can follow it on my association's website or the Luos social media, which will give you some news about it. I suggest you discover the other videos and all the content on the Luos YouTube channel. Many interesting projects are presented there. Feel free to like, comment and share this video. Thanks for watching until the end. See you next time.